Alright, continuing mission. I think, let's check our DRC. We have 20 air wires, which seems like a lot. Most of them are grounds, I believe, which will make things really easy once we make the ground planes. Yeah, that should be no problem. Let's do rats, see what we get here. Some of them go away. We show ground. We see the whole bottom is a ground plane. On the top, display minus bottom. If we look at the top, we see the grounds are a little more broken up. So pretty much we have the grounds and the noisy grounds still to connect. And we have one more 5-volt connection here that we need to connect. Or we can make it here. And we're going to make it here because it's really easy to make this. So we see we have a ground here that gets cut off. We can put a via if need be. And then we have this one. We're going to want to put a via here. Let's go ahead and do that now. So do via, name it ground, drop it right here. We can do one here as well. It's important that this is connected. And one here. We want them to go straight to the bottom ground plane as quick as possible. We have some of these grounds. Let's drop some more vias. Again, as close as possible, straight to the ground plane on the bottom. Here, this capacitor is completely isolated. Here has a ground plane being generated on the top, but that has no connection to this ground plane or the rest of them for that matter. This is just the closest ground connection that needs to be made that the DRC shows. And if we do rats, you'll notice that now it's connected and it's connected through the bottom. We lose out on a little bit of ground plane here. We can put a via here and then generate it, but honestly it probably won't save us much. We can even push the capacitor down if we wanted to like maximize the ground plane elsewhere, but we'll let that one slide. So we have the noisy ground. I'm going to ignore those for now and do those towards the end. But if you do notice, we do have the grounds here that we're going to need to take care of, and we'll do that in just a moment when we address the ground plane here, because we are going to have a little bit of interesting setup. Let's do the grounds for our voltage regulator. So we want a couple vias here. Similarly to the remote, this voltage regulator is not going to pull a lot of power. It has more to power than we did on the remote, but again, very low amperage, it's not going to get hot. But just want to show you guys in general, you'll want a couple vias, you'll want a nice big ground plane here so that it can dissipate heat. But again, in this case, it's not that big of a deal. But it's good to see the practice, or if you see on some other boards why they have a lot of vias around there. And then the two grounds, or the two vias for the grounds here, so they go straight to ground as quick as possible. We should have one here as well, and then one for each of these capacitors. I think I did the one on the other side. Here we're not going to put a via to connect this to ground. We might do it for this one, but for this one it's not that big of a deal. Again, we'll only be saving a little bit, and we could have alternatively made another joint for all these if we really wanted to save on some of the ground here, and again make this a little bit shorter. Also here we can probably just route the 5-volt along the edge. Let's go ahead and do that. Alright, so we got a little bit more back, making use of some of the space. I'm not going to worry about this. It's up to us if we want to play with maybe the placement of this. Maybe having this ground plane more filled is better, but not a big deal. Sure, it'll be fine. It's not going to make much of a difference. Alright, looks like we're about ready to adjust the noisy ground, and we'll fill in this plane here. So let's rip, let's bring back our bottom, and let's go ahead and make the polygon for our noisy ground. So polygon, 6 mil here. We want it to be on the bottom. We'll probably make one on the top as well. And let's just start somewhere. Noisy ground will be something like this. Again, you can go out of the plane. Sometimes I like to go out so it's easy for me to rip it up or see that there's another one. We're gonna call this one noisy ground. And we're getting this error because of rank. So if you guys haven't been introduced to rank yet, if you look at the ground planes, if you have 2 or more power planes on a single given layer, then rank's going to matter. So the plane with the lowest rank, in this case 6, will be drawn first. So 6 will be drawn, and then 5, 4, 3, 2, 1. So if you have 2 or more planes with the same rank over each other, then there becomes a conflict on which one to draw first. So in this way we can actually draw, we don't need to modify the ground here. We can do the noisy ground over it, and as long as the noisy ground has a higher rank, in this case it's 1, but we can make it 5, 4, 3, 2, or 1. As long as we don't make it 6, then Eagle won't get confused on which one to draw first or which one takes precedence. So if we do rats, we'll see that if we show ground, our ground is on the top and the bottom. So on just the bottom we see all this ground, nice and continuous, a couple little spurs that we're already aware of because we had to cross over the powers, but notice how this is along along the edge, so it doesn't really affect the ground plane. If we had gone this way instead, it would have destroyed some of the connection we had here, and so we did a pretty good job. But that's because I had gone through several iterations of trying to minimize any perturbations to the ground plane. So let's modify our noisy ground a little bit because I missed the connection here, and it'll take a little bit of finagling around to get it covering everything we need to cover. So let's look at noisy ground, and it looks like everything that we need to connect except for this is on the top. So we need to make one on the top layer before we can see something meaningful. So bring back the top. I'm going to get rid of the bottom. Actually, I'm going to cheat again and just copy this, put it in the same spot, info, change it to the top layer. And again, we're running to the same rank problem, so we'll solve it the same way. Now we have to look at the top plane, change its rank to 6, or we can change it to 2 just to show you guys it still works. Now when we do rats, this is the bottom. If we toggle to the top, we'll notice if we show ground, we kind of ripped some of our connections here because that's where our noisy ground is. And if we show noisy ground, here are the connections. Now we can also see where our noisy ground is actually connected and where some of the space is. So let's maximize this space here for our noisy ground, or shoot, rather, we still have the ground of the servo to consider. So we'll probably have on the bottom, we'll have ground cover the connections for our servo, but on the top, we'll cover this with our noisy ground. So this is where we're going to be really careful, and our ground planes on both top and bottom will actually differ. So it's okay to go over the signals. When you do the rat's nest, it'll only cover what's available to cover. So it may look kind of weird that I'm covering the routes we have, but when it does the fill, it'll only do where it can be connected. So there, nice and continuous, or at least as continuous as we can make it. The capacitors here, it may look weird that it's kind of disturbing it, but it's actually nice that we'll force the signal through here and immediately join the noisy ground. We can actually reduce our noisy ground, maybe push it over a bit, and let our regular ground have this, because all this is continuous with that. So when we go back to it, now if we see our ground, it's nice and continuous here, but again, we're interrupting it here. So we kind of have this interesting trade-off that's starting to go on. But in order for us to combat that, we're going to need to modify our ground. And let's see, let us move it a little bit over, look at it one more time. So this part isn't covered. I think I might just let this one go, it's not a big deal. On my board, I had the placement a little bit better, or a little bit different, such that I kind of made it nice and evenly partitioned. We'll live with this. If you guys really wanted to, you can massage it around, but it's not worth the trouble. And we can always use the tool split to actually break up, to remodify our polygon, and we could cut it in like that or so. And then we would get our ground, and we would be happy with our noise ground. Okay, so next, let us see what we have left to do, because it looks like almost everything's connected. Let's check out our bottom real quick. So our ground, nice and continuous. This worked out to be pretty nice. So by making our noisy ground so close to this, might have been coincidence that this seems, if it wouldn't have had a loop here to go around it, so that's good. So it's kind of nice that it's like right along the edge. We could probably move it over just a bit and kind of make some room for it. It seems like this connection is not done, so we can move this down a bit, give it some more room for our ground to connect. You can also take advantage of this via and use it in our favor, such that we can kind of just maximize the room we can take up there. That looks good. So our noisy ground, nice and continuous, and if you notice, it connects to our net bridge right here, perfectly in the center, and our ground is here. So we can see this is exactly where the noisy ground is going to hit our regular ground, and then it'll make an immediate connection into our battery, which is exactly what we want out of it. Just to make it so we don't interfere with the pad a little bit, I'll slide this over a tad. Yep, that looks good. So again, it'll connect through here and run straight into the ground. So our reference voltage will appear to be as close to our battery reference as possible. We brought this back a little bit. We can rewire it on the bottom if we choose. There we are. So we kind of keep the continuity as much as possible. We can even massage it on the top and put the vias in a better spot. Anything else standing out? This can't really help it. Maybe we could have pushed it back and then route the top like in and out here, but again, that's fine. It really depends how meticulous you want to be and how much you want to save. This we can let go, it's okay, it's very small. Some of these things won't make a difference. We can probably push this over to the side. That wouldn't be a bad idea to do, but that's really up to you guys if you want to play with it. I mean, I encourage that you guys kind of play around and massage it and really just get used to using the tools and then trying to maximize these planes for better connectivity and conductivity. Let's go check our DRC. It says we have one air wire. Oh, and we saw this earlier. So let's just make this easy. Normally I want this to go to ground as soon as possible, but we'll just take advantage of the fact that the devices are so close together just to make this connected. And that's fine. That means it's just nice and through the servo. DRC once more. We see a couple wire stubs. I love the new Eagle update that finds these for you. We also have 3 T keep out errors, so this got moved down a little bit. Let's move it up just a hair. If you need to adjust. This looks fine to me. We got some overlap here, so the neck bridge will always cause an error like this, and it's okay, you can improve them, and most manufacturers, or all the ones that I've used, don't have any problems with it in manufacturing, so we don't need to worry about it too much. Alright, so I encourage you guys to scan over everything, top and bottom, be very meticulous, massage things around if they need to be, but other than that, this looks good. It looks pretty damn similar to the board that you guys made. The only difference is that on the board that you guys are using, you might have a giant hole here in the current revision that we're using, and this was so that you can secure it to the chassis of the board, and so you guys can go ahead and add that. I'm not going to add it, it's not terribly important, and the reason why we picked this position was because there wasn't really any other space to do it. Some more things we need to do is we need to add some vias to the noisy ground. So again, we want these to dive in as soon as they can to the noisy ground plane. For the noisy ground 2, we're going to get an error as you can see here because it does have the exposed pad, but we're going to put some vias on this pad itself. It's okay, most manufacturers are okay with it, and the reason why we're doing this is to help with soldering and also to dissipate heat, and of course so that it goes straight to that ground plane immediately or as soon as possible. Put one here on the end of these pins. Alright, so when we go back to the DRC to check this, we'll notice we get errors here, and you guys can go ahead and approve those. They should be fine. Anything else you need to connect to ground? Doesn't look like it. Alright, so this noisy ground is going to get very hot, so we're going to do a couple more stitching between the top and bottom layers of the noisy ground. So these are some thermal vias. This will be to the normal ground, careful. It's kind of hard to see, but it's on the bottom there. These were close too, but that should be fine. Maybe one more right there and that should be good. And same for the regular ground. We'll do a couple stitching, not important, these ones aren't for thermal. Put another one here if we wanted, probably not necessary. Put one here, careful to put it over there. You might want to see that indicator later when you're soldering. The ground here kind of got a little wonky on the top. It's unfortunate, but it should be fine. It has a nice connection on the bottom. If we want to restore any of these grounds, we can just put one there. But again, we won't get much out of that, so I don't really care about it so much. But feel free to do it if you're interested. And here, again, spotty on the top, but nicely connected on the bottom. Alright, I think this looks great. Final things we want to do is check DRC one more time. We have our 8 approved errors. We got to add some swag to this. That's the last thing we have to do. And then we'll see what it looks like in our 3D model.